Okay, so what do you think?
I think the answer would be A and B and any of those four, C, D, E, or F.
All right, so let's think about what would happen in that case. So if we start off the centers there, the first step is going to be for every point to join whichever cluster it's closest to. So A is just going to be with A,
Mm-hmm.
B is just going to be with B, and then D is going to slurp up all these other 4 points.
Right.
All right, so now in the next iteration, it's going to recompute the centers, and A and B aren't going to change. This cluster, the center is going to change to here, and now it's never going to make any additional progress. So those are the 3 clusters it'll find if it starts off with those kind of bad initial points.
So how would we go about avoiding that sort of thing?
Ah, yes, I was going to ask you exactly that question. So given that we're thinking about this as a hill climbing process, that's a local optimum, and we had a pretty good way of dealing with local optima, and that was random restarts. That's one possibility. Another thing that people sometimes do is they'll do a quick analysis of the space and actually try to find initial cluster centers that kind of are spread out. So pick a cluster center and then pick the next cluster center to be as far away from all the other cluster centers as you can.
So kind of do like the, I don't know, the convex hull of the space and try to pick points near the corners or something like that?
Ish, yeah, that's right.
Hmm. So I think you've done another thing too, now that I say that out loud, which is you've been choosing these random places to start your centers as always being one of the points. I guess you didn't have to do that,
Yes.
but it probably helps that you do.
It certainly keeps the centers near the points. Another thing you can do to get things started is just randomly assign everybody to clusters. But that can often have the property that all the centers of those clusters end up being kind of really close to each other. So by picking points to be the clusters, it does have a tendency to spread things out.
Okay, that makes sense.
That's not a proof, though.
No, proof by that makes sense.